These are the notes for 10.7. You want to use your note packet for this, but let's review really quickly. We want to find the median and the IQR for each set of data. You're talking about some male students in 8th grade and 6th grade and their shoe size. So you want to find the median and the IQR. So pause the computer, and when you're done, turn it back on. Okay, you should have found that the median was 8 because that's the center of your data, and the IQR is the upper quartile, which is about 9. Subtract the lower quartile, which is about 7.5, and that's how you got 1.5. For 6th grade, your median would be 6, and then you've got your upper quartile of 7 minus 5.5, which gives you your lower quartile of 1. We're going to be finding medians and quartiles quite a bit today, so we'll want to focus on that. Go ahead and turn to your notes, and we're going to talk for a minute before you take notes about symmetry. So sometimes data, it looks exactly the same on both sides, and we call that symmetric data. And sometimes it's skewed one way or the other. In this case, it's skewed to the right because it leans to the right. If your data is symmetric, when you calculate, your mean and your median actually work out the same. But when it's not symmetric, these two get away from each other a little bit. So our focus for today is to find out if things are symmetric or not, and then we'll go over this again, but basically you need to know that if it is symmetric, you use the mean and the MAD when it's symmetric, and when it's not symmetric, when it's skewed, you're going to use your median and your IQR in order to find out how to interpret your data. So let's look for a minute on each of these, determine if you think it's skewed or symmetric. This one would be skewed to the right in both cases. This one would be symmetric. Skewed or symmetric. This one would be symmetric. Skewed or symmetric. Here we're going to be skewed to the left because our data goes off to the left. So that's what we want to look at today, is knowing if things are skewed or symmetric. Before we jump into our notes, let's review. We talked last time about mean, median, and mode, and we talked about how those are measurements of central variance. They measure the center of the data. Mean, median, mode do. They're measures of central tendency, and variance would be the range, interquartile, and MAD. And each of these involves subtraction. So when you're subtracting, you're dealing with how much it varies. So the question for today is, what measurement is best to use to describe the data? If you have a symmetric data, you're going to use the mean and the MAD to describe it. And so I make this little guy right here, he's symmetric. He's mean and MAD, so that kind of helps you remember that's what you're going to use there. And you use the median and the interquartile range if it is skewed, either to the left or the right. So you'll look at your data and determine which points to use. So on your notes, we're on the front side of your notes about halfway down, and you looked at these before and kind of crunched the numbers. But now we're going to ask some questions about it. So first of all, do they overlap? We're looking at hours of sleep that males and females get, and they do overlap. We've got a lot of points in common. And looking at this lower one is skewed, whereas the upper one is almost symmetrical. But if any of the data is skewed, you always use the skewed data, which we said would be your median and your interquartile. So pause this and find the median and the interquartile, and then go ahead and turn your computer back on, and we will look at your answers to it. Okay, you should have found your median and your mode, or your IQR. So for males, your median would be right here at 8.5, and your IQR, when you subtract these, would be 2. And then for females, you would see that your median's 9, and your IQR is just going to be 1. Now, what does that mean about the data? Because we want to interpret data today. So here we're looking at this, and one thing we noticed is that we could definitely say girls get more sleep. Okay, it's not tons, but about half an hour more of sleep. However, we can see that with an IQR of 1, all of 50% of the data is within 1 hour of that. Whereas here, 50% of the boys are within 2 hours. So you can see that the girls' data, 50% of girls get between 8.5 and 9.5 hours of sleep, whereas 50% of boys are between 7 and 9. So you can see overall, boys are getting more sleep. So that's how we would interpret that data. Here's the next one. Looks like we've already got the answers on that one. Did I skip things? Oh well, answers are in there, but let's look at it. They're both symmetrical. So in this case, since they're symmetrical, you're going to use your mean. And so we found the mean for this. We did this yesterday, which was 62, and the mean for females was 60. But your range was the same, both within 6 inches of each other. So in this case, actually, the median was also the same as the mean because it's symmetrical data. The last one that we looked at yesterday was the exercise class. One meets at 10 in the morning, one meets at 8. Are they symmetrical? If you look at this first group, they're pretty much symmetrical. But this next group is very skewed. So if one side is skewed, they're both skewed. So you're going to want to line your numbers up and find the median, because with skewed data, you want the median and the IQR. But we'll just look at the median here for this data. So pause the computer and turn it back on when you're done. Okay, there is no overlap in this case because the oldest person for the class was 40 years old, whereas the youngest person for the next class was 42. If you count the middle number, you should find out that 29 is your middle number. Actually, these two are both middle numbers, so it'd be 29, and the median would be 53 for the older class. And so you can interpret the data in that way, showing that your median age for the younger class is 29 and the 53 for the older class. You can also look at your range of your least and greatest, and maybe even talk about why. Why are older people coming to a morning class? Maybe they don't have to go to school or work. Maybe their kids are in school. So interpreting data, that's what we're looking at today. All right, turn your notes over to the back. And before you do the work there, let's just ask ourselves on each of these. Look at it. Is it skewed or symmetric? And in this case, one of them skewed. And if one of them skewed, then we'll have to do the skewed method, which is your median and your IQR. Skewed or symmetric? In this case, they're symmetric. So you would look for your mean and your MAD. Skewed or symmetric, we already talked about this with our exercise class. One of them skewed, so the entire thing will be skewed. That's our question for today. Is it skewed or symmetric? So on the back of your notes, you might want to highlight some things. This is our focus for today. Use the mean and the MAD if it's a symmetric distribution, and the median and the IQR if it's skewed. So you might want to highlight that this last paragraph, super important. When you're going to compare two populations, okay? If it's symmetric, you're going to use the mean and the MAD. That will be your best comparison. And if it's skewed, that's when you would use the median and the IQR. When one or both are skewed, so even if just one of them is skewed, the entire set of data is skewed, and you will want to use your median and your IQR. So let's look at these examples. Your first example is dealing with a candidate. Two candidates. They're both asked 15 questions, and they're timed on their answers. So candidate A, shortest time was 50 seconds to answer, and B took 120 minutes. A took 120 for the longest. Candidate B was able to answer 3 of the questions in 30 seconds and 2 questions in 90. So we're looking at this, and it's pretty symmetric. You're really just missing a dot here or there to make it exactly mirror image. So we know that they're symmetric. So ask yourself, what data will you use if it is symmetric? And in this case, we know that we need to find the mean, and we also need to find the MAD. Now, it would take a lot of time for us to find the mean and the MAD of this data. And since we're interpreting data, I'm going to give you that information, and you're going to make some interpretations. So write down the mean and the MAD. You want to write down that your mean for candidate A is 84. So it took an average of 84 seconds for him to answer each question. And for candidate B, it was 58. Now the MAD for each of them is actually 16. Which means, since they both have a variableness of 16, when your variableness is the same, it makes the comparison more valid. So it's just nice to check if your variableness is the same, and now I can compare. And I can make a conclusion about my candidates, and think what your conclusion might be. Some people say, my conclusion is that candidate B is able to answer things more concisely, and I like him. Some people might say candidate A, he just talks too much. Others might say candidate B doesn't have much to say, whereas candidate A is much more informed on the topic. So it kind of depends on what you're looking at, how you want to make your analysis. All right, let's look at our next comparison. Now we're talking about the cost of speeding tickets in 2 states. And it says the double box whisker plot shows a random sample of 10 speeding tickets issued to 2 states. Compare the samples using measures of center variation. And then it says, can you use this to make a valid comparison about speeding tickets in the 2 states? So state A and state B, skewed or symmetric. In this case, it is skewed. So write skewed over to the side. And so with skewed, what do we use? We're going to use our median and our IQR. So take a minute and find the median and IQR for each set of data, and then turn it back on, and we'll talk about it. Okay, for state A, you should have found that your median was 70, and your IQR when you subtract 80 from 60 is 20. For state B, you should have said your median was 80, but your IQR from 100 to 70 is 30. So now my IQR is a little bit off, so I know that the data is a little bit more spread out, but I can say that I know that state B has a median price of $10 more per ticket. Now the question says, can you make a valid comparison? And I'm going to propose to you, you cannot. So I want you to think why you can't. And look in particular at this. It says you do a random sample of 10 speeding tickets. Is that enough data for 2 states to get 10 speeding tickets? That would be insufficient data. So it says, can you make a valid comparison? You're going to say no, cannot, not enough data. There's surely more than 10 people who got speeding tickets in those 2 towns. So now let's look at your last one. This one says the double box and whisker plot shows the medians of 10 random samples of 10 speeding tickets. So in this case, we've got 1,000. That's a much better sample set, so this is going to be much more valid information because 10 sets of 100 sets of 10. So here's your box and whisker plots. Now, skewed again, right? One of them skewed, so they're both skewed. So I'm going to have to use my median, my IQR. So find those and then turn the computer back on. So median for state A would be around 65, and your IQR is about 10. Median for state B would be 80, and your IQR is about 10 again. Now, my IQRs are the same, so I can see my variableness is similar, so that helps in comparison. And now I can say with more confidence, having 1,000 different bits of data, that it is more expensive to get a speeding ticket in state B than state A. The bottom of your page, it asks you to write a conclusion, make a conclusion about the cost of speeding tickets in the 2 states. So you write down your conclusion. Obviously, you shouldn't speed, but what's your conclusion about what the states are making in revenue through tickets? Write your conclusion to them. Now that's the end of notes, but I want to look at 3 last situations. This one is with hockey. So you've got a box and whisker plot, skewed or symmetric. This one's definitely skewed. So you would use your median and your IQR. So here's your data. That the median is 3 and the IQR is 2. For team A, team B, median 7 and IQR of 2. Now my IQRs are the same, so I know the data is valid. And I can definitely make a conclusion then about team B. They had a much better season, and they scored usually 4 points more per game. So it's important to be able to compare them. Let's look at the next one. I'm talking about snow over 16-week period, so about 4 months, in City A and City B. Now in this case, they are symmetric, but you cannot find a mean because you don't have enough data. You lose the data when you do a box and whisker plot. So even though it's symmetric, in this case, you have to use the median and the IQR because that's the only data you can collect. So you would use your median for each of them. It would be 3 and 6. But your IQRs are the same at 4. So the variableness is the same, but City B gets 3 more inches than City A. So you can decide where you want to live depending on how much you like snow. Finally, test scores. Got 2 classes, skewed or symmetric. In this case, they are skewed. Which class would you want to be in? It says the same teacher taught the classes. These are their grades on their tests. Class A did much better. To get the data for this, because they're skewed, you would need to gather the median and the IQR. Our medians are a little off, but fairly similar. or sorry, our IQRs are a little bit off. Our medians for Class A is 90 and Class B is 80. So you can therefore conclude that Class A gets about 10 points better for thing. So that's your information looking for whether things are skewed or symmetric and how to know which data to use. So now you can work on your worksheet for this section.